Good afternoon, ladies and gentlemen. Today we're looking at Unit 1, Lesson 1. And our objective today is to write an equation of a line using Desmos. Now, if you recall from the Desmos activity we did earlier, that the equation of the line can be written as y equals mx plus b, where b is the y-intercept and m is the slope. So if I am given a line, as I am in this graph, I should easily be able to find the slope. So remember, slope is rise over run. So if I were to find the slope of this line, I went down 1 and to the right 1. So my slope is -1. And I notice that because it is going down from left to right. I just need to find any ordered pair on this line. I can choose any ordered pair, but since this one seems like it's already marked, I'm going to choose that ordered pair, which is -1, 2, 3. X is -3, and Y is 0. And I'm going to use this information to find B on Desmos. Now, the first thing I want to do, according to our notes, I wanted to graph the ordered pair. So the ordered pair is -3, comma, I may need to put that in parentheses. Yes, I need to put that in parentheses, -3, 0. Okay, notice it put my little ordered pair. I'm going to make the screen bigger so you can see. -3, 0, it marked that point. And then I'm going to come down into the next one and I'm going to write an equation of the line. -x, and I'm trying to find b, so I'm going to say plus b. I have to go to ABC to get b. Now it wants me to add a slider. So I'm going to add a slider just by clicking on it. And what this slider will allow me to do is to determine what's the value of b. Notice the line that they have drawn now is b equals 1. We see it's crossing the y-axis at 1. We want our line to go through this point, -3, 0. So I'm going to just slide my slider. I notice if I slide my slider to the right, the line increases. I'm going in the wrong direction, so let's try sliding it in the left until I go through, oops, a little bit off. I go through the point. The line is going through the point, and from there I can determine that my y-intercept is -1, -2, -3. We can just also press on it and it'll tell us that our slider B is -3. Okay? So B is -3. And so because B is -3, then I can write my equation of the line as y is equal to -x plus 3. Also notice that I could have done that without doing the slider. If I continued the pattern, the pattern with the slope and go down 1 and to the right 1, notice I also would have gone through that line, through -3. So that's another way that I can do it, is I can continue the pattern on the slope. All right, let's do another problem. We'll do the next problem. We have to find our slope. We want to draw a line. Whoops. So I went up 2 and to the right 1. And this time my line is increasing from left to right, so my slope is 2. I need to find an ordered pair on that line, and I can use either ordered pair, either endpoints. Let's choose this endpoint. And what's the ordered pair associated with that? -1, -2, -3. I'm sorry. Well, this is -5. 1, 2, 3, 4, 5. That's -5. So this is -6 and 1, 2, 3. -3, -6. Because it's always x, y. So I went to the right 3, 1, 2, 3, and I went down 6. So it's -3, -6 will be my ordered pair. And we want to know what B is. So we're going to go back to our handy dandy Desmos, and I'm going to change my ordered pair to -3, -6, comma, -6. Notice it's sketched it for me. And then I'm going to change my equation, because now my equation is 2x plus b. And I get that 2x because remember I found my slope to be 2. So I get 2x plus b. And again, I'm going to choose my slider. So if I move my slider to the right, I can see that it's intersecting that line. And my b is going to be 0. It's a little bit off there. Here we go. So my b is 0. Oh, actually, my b is a little bit off. So it looks like my b is 0.2, maybe. Let's go right through there. There we go. It's 0. My b is 0. So my equation is going to be y equals 2x. Okay? Let's do another example. So if you want to pause the video and you want to do the example for the next one, that would be great. Okay, so welcome back. We see our slope is -1. If we choose an ordered pair, and you may have chosen a different ordered pair than I did, and that's okay. My ordered pair is going to be 4 and 1, 2, 3, 4 and -3 is my ordered pair. So my ordered pair is 4, -3. 4, -3. And my y is going to be, my slope was -1. And my b remains, so now I'm just trying to get it to go through that point. Let's go up 1. And so it looks like my b is going to be 1. If I go straight through that point, my b is 1. So b is 1. My ordered pair was, the one that I chose was +4, -3. And so the equation of that line is going to be y is equal to -x plus 1. Easy peasy, boys and girls. Okay, notice that most of these lines, it did not go through the straight line, that the graphs had a domain, had a restricted domain, meaning that they didn't go on and on forever. They had a restricted domain, and so now we're going to talk about how to find that restricted domain. And to do that, we're going to do that with what we call piecewise functions. So a piecewise function, in your notes, what you want to write is a piecewise function is a function divided into pieces. See how easy Math 3 is going to be? It's a piecewise function. It is several functions written together. It's several functions written together. And so far this week, we're going to deal mostly with linear, but we also will deal with quadratic and absolute value piecewise functions. All right, so notice that this function has two pieces. It has a linear function with a positive slope, and then it has a horizontal function. Now, when we write this horizontal function, when we have a horizontal line, our equation is simply going to be y equals. And because it has a slope of 0, and it crosses the y-axis at 1, 2, so it'll be y equals 0, x plus 2. Or we normally would just write that as y is equal to 2. Now, where does this graph start? Notice, and it may be hard to see on your paper, but that's a closed circle. So what x value is this starting at? This starts at -2, and it goes on forever. So we're going to say that x is greater than -2. And we're going to say greater than or equal to because we have a closed circle. Now, the other part of our graph is defined when x is less than 2. And it's not less than or equal to because it has an open circle. So it's less than or it's greater than or equal to when it's closed. It's just less than when it's open. So how do I write the equation for this line? I'm going to do the same thing I did above. The first thing I'm going to do is find the slope of this line. And that slope is y equals 1x because the slope is 1. So I'm going to change this to, whoops. I don't know what I did, so I'm going to start all over again. So I have an equation of x, 1x plus b. And yes, I want a slider. My next equation is my ordered pair. So I can choose any ordered pair on this. If you want to choose the endpoint, you can, but you can choose any ordered pair. And my ordered pair that I am choosing is x is 1, 2, 3, 4. X is -4. Comma, and y is 1. I'm having a hard time finding my letters. There we go. My numbers, rather. Okay? And we can see that it put it on that graph. So now to find that y-intercept, I'm going to use my slider. And as I move my slider up, I see that that's going to go through that point of, it's going to have a y-intercept of 0. Nope. A y-intercept of 5. I don't know where I got 0 from. It's got a y-intercept of 5. If I can get it on there. Yeah. It's got a y-intercept of 5. So my equation is going to be y is equal to x plus 5. Because b is 5. And where is it defined? I've already said that it's going to be defined when x is less than -2. And because there's an open circle, we don't put a line. So if we have a closed circle, we put a line underneath the inequality. If it's an open circle, there's no line under the inequality, meaning that that number is not included in the domain. Okay? Now this one has 3. How much fun is that? So let's look at the 3 different functions. Let's label them A, B, and C. So when I'm talking about them, you'll know which one I'm talking about. Let's start with A. We can see that A has a slope of 1. If we want to see what the y-intercept is, we can continue that pattern. We can go up 1 and over 1, and it looks like it's going to cross the y-axis at 1. So instead of using Desmos, I'm just going to go up 1 over 1 and say that crosses the y-axis at 1. Now, this graph has a closed circle. And where does it start? It starts at x equals -1. And it's defined for all values less than -1. So it's defined for all values over here. So I'm going to say it is x is less than -1. And it has a closed circle, so it has a line underneath. When I go to the next line, when I go to B, I notice that I can already tell you, and I lied to you, that has a y-intercept of 2. Sorry. Because if we continue that pattern, we go up 1 over 1, it has a y-intercept of 2. So for B, B also has a slope of 1. So we know this is going to be x. And we can look at it and tell it has a y-intercept of 1, 2, 3. It has a y-intercept of 3. Now notice it's between 2 points. It's between -1 and 1. Also notice because there are open circles on both ends, it's going to be 1 is less than x is less than 1. It's between those values. We're going to have open circles. And so we will not have a line under our inequalities. And then for C, that's a closed circle. It too has a slope of 1. If we want to see what the if we wanted to see what the y-intercept was, we continue that pattern. We go down 1 and to the left 1, and we see that it has a y-intercept of 1. And it's defined x is greater than 1, but it would have a closed circle because of the closed circle here. I mean, it would have a line underneath it because of the closed circle. So if it has a closed circle, it's going to be less than or equal to or greater than or equal to. If it has an open circle, it's just less than or greater than. That's something that you need to know. Okay? For the next one that I'm going to do, I'm going to use Desmos to write the equation of the line. This one has 3 parts. It has this linear part, and then, well, they're all linear. It has a linear line, and then it's horizontal, and then it's a negative slope. So let's look at our three parts, our 3 functions. The first one has a slope of 1, 2, 3. We rise 3, we go over 1. Now, I don't know what b is, and it's a little bit more difficult to find because if I go 3 up 3 over 1, I'm off the graph. So let's use Desmos to find what our b is. So again, we're going to do 3x plus b. And we're going to find an ordered pair. We can take any ordered pair that we like. Let's do, I like that ordered pair. This ordered pair is 1, 2, 3. So negative 3 and 1. So that's my ordered pair. So I'm going to put in negative 3 and 1. 3, comma, 1, comma. All right, so we can see that they've graphed that for us. We have 3x plus 1. Now we need to move our y-intercept. So I'm going in the wrong direction. I'm making my y-intercept smaller. I'm going in the wrong direction. Let's go in the right direction and see what would be the equation of this line. And it looks to me like it's going to be 10. I'll move it just a little bit over. I have no idea what that is. So it's going to be 10. So we have 3x plus 10. For part B, it's a horizontal line. It has a slope of 0. So remember, when we have a slope of 0, the equation is just y equals. And where does it cross the y-axis? 1, 2, 3, 4. I'm sorry, so this would be y equals 4. And then for my last one, I have to see where it crosses my y-axis is for this one. So it also has a slope of 3. It has a slope of 3, but it's negative. So this would be y equals negative 3x plus b. And I need an ordered pair that it's going through. So what ordered pair is this going to go through? So this is x is 1, 2, 3, 4, and y is negative 2. So we're going to go through the ordered pair, 4, negative 2. 4, comma, negative 2. Oh, it's already going through it. So it still has a y-intercept of 10. So it'd be negative 3x, because I can see it's going through 10. Even though it says 9.7, I'm pretty sure that's 10. So it'd be negative 3x plus 10. Okay, now I have to go back and do my domain. So this is broken up here and here. So my domain for for A is x is less than negative 2. Now, is it greater than or equal to? It doesn't matter. It's closed, so I can make it less than or equal to. And then 4 would go from negative 2 now, I noticed that I didn't put a line on both less than or equal to and greater and less than here. You can. I choose to put it on just one since it's covered. And so for the next one, it's going to be x is greater than 2, and I would probably do greater than or equal to there. Okie dokie? Alrighty. What I would like for you to do is I would like for you to try the next two and then come back. So pause the video, try the next two, and then come back and see what my answers are. Okay, welcome back. This one has 3 parts, so I'm just going to write them real quick. We have y equals, it's piecewise function, now has the y equals. So y equals 1, y equals 3, y equals 5. And my restrictions are, it's a closed circle here, closed circle and closed circle. So my restrictions are from x is between 0 and 2, and it's closed on 0. It's between 2 and 4. Yeah, 2 and 4, and it's closed on 2. And this one's between 4 and 6, and it's closed on 4. Okay? For the next one, we have 2 equations. They both have a y-intercept of 0. So this would be 2x when x is greater than or equal to 0. And it is 1x when x is less than 0. Now, if you had greater than and then less than or equal to here, that's the same. I still would count that as correct. All right, let's do the last 2. And then in the next video, we'll look at evaluating a function. All right, so for this next 2, we're going to do the exact same thing we did before. We have 3 parts. So for this first part, I can see I have a slope of 2x. If I want to find out my b, I can continue that pattern, up 2 over 1, up 2 over 1. And I will see that the b is at 1, 2, 3, 4, 5, 6. But if you don't like that, we can use our handy dandy Desmos and make this 2x plus b positive. We can make that 2x plus b. And our point that we wanted to go through, we can do -2 and +2. So we can do -2 and 2. Okay, and so I'm going to slide my b to get it there and see if I get the same thing I got before. Yep, look like it is at 6, so 2x plus 6. The middle one is a horizontal line, and it intersects at 1, 2, 3, 4. So that one would just be 4. And the last one has a negative slope of 2. And it's going to be probably a little bit more difficult to see where it crosses the y-axis. So I go up 2 over 1, up 2, because it's going to go off the railing. So I'm going to use Desmos. So I have -2x plus b. And my point is, let's just take 1, 2, 3, and 1. I'm just going to do this point here, 3, 1. So I'm going to take the point +3 and +1, 3, comma 1. And let's see, if I move my line, I get, it looks like it's 7. Okay, I don't know what that is, but I think it's 7 because it needs to come over just a tad. Yeah, so it's going to be -2x plus 7. Again, doing my restrictions, this one would be x is less than -2. Open circle, so therefore no line. This one would go from 2 to 2. There's a closed circle here, so I'll make that less than or equal to. And this one would go from x is greater than 3. It's a closed circle, so I would make it greater than or equal to 3. Okay? All right, and then let's do this last one. This is what we call an absolute value function, and we're going to talk about that later in the week or early next week. This is absolute value. And it looks like a V. And what we're going to notice for this absolute value is that the slopes are going to be, one's going to be positive and one's going to be negative. So this one has, on the left side, it has a slope of -1. And if we want to, what point is it going through? This point is called its vertex. And its vertex is at 1, -3. So that's the point that it's going through. So let's write our equation. We have -x plus b and my point is going to be 1, -3. And I chose that point so I don't have to change it when I do the next part of it. 1, -3. So I want to get it to go through that point. So I'm going to slide my b over until I get it to go through that point. And that point is, looks like it's going to be, my y-intercept is -2. So my y-intercept is -2. Okay? So to do the next one also has a slope of 1. Okay? And it goes through that same point. So I don't have to change my point, and that's probably, it's going to have a y-intercept of -3, -4. So this one would have a y-intercept of 4. -4. Okay? And now let's just go through and write our restrictions. So my restriction, it starts at negative. Why did I say negative? It doesn't. It has to be x is less than 2. And the next one will be x is greater than 2. And that's not true either. I don't know where I got that from. The vertex is 1. So this is my vertex. So this is x is less than 1 and x is greater than 1. And you can choose where you put the less than or equal to or the greater than or equal to. It doesn't matter. I'll just put it on the first one. Okay? All right. That is how we write an equation, and that is also how we write an equation for a piecewise function. So I want you to watch the next video, which is going to help us evaluate a piecewise function. Okie dokie? Okay, welcome back to lesson 1, video 2. In the previous video, I think I lied to. I told you we were going to evaluate a piecewise function, but that will have to wait until tomorrow. What we're actually doing today is graphing a piecewise function using Desmos. All right, so you will notice we're on page 5 in your notes, and you will notice you have a piecewise function. You have x plus 2 when x is less than -2, and it's a -4 when x is greater than -2. I'm going to show you how to do this in Desmos, okay? Because on the exam, you pretty much just have to be able to match the information, okay? So what we're going to do is we're going to put in that first equation, y equals, and this time I think you need to use y equals. So we're going to do y is equal to x plus 5. Easy peasy. We got a nice pretty graph. Now, we're restricting that graph for x is less than -2. So how do I put that restriction into Desmos? Well, we can go to ABC on there if you don't already have that up. And you want to choose the little, the one next to the bracket, the one that's got like a little squiggly line, the braces is what I call braces. And then you're going to type in the restriction. So our restriction is, go back to your functions, x is less than -2. Easy peasy. Notice how it restricted that line. It is no longer going through everything. It's just only going through x is less than 2. All right, so let's go down to the next one, and now we're going to do -4. And we're going to restrict it. So we go to ABC, we get our little braces, and this time we're restricting it as x is greater than or equal to -2. Okay, and notice that it has restricted the graph. Now, what do I need you to be able to do? I need you to be able to show me where it's closed circle or open circle. So we graphed it on Desmos. Let's graph it on our paper. We have a y-intercept of 5, so I'm going to make this bigger. So we have a pretty good idea of what it looks like. So we have x plus 5, so we have a y-intercept of 5, and we're going to have an open circle there. I'm going to put an open circle because it's just less than, and it has a slope of 1. So I'm going to go down 1 and to the left 1 because that's what it looks like on Desmos. And I'm going to draw my line, and I'm putting an arrow on it saying that it's going to go on and on forever. And then if we notice on Desmos, our -4 is a horizontal line because it has a slope of 0. We have a horizontal line that starts at -2, x is -2. And so I did that incorrectly. Please forgive me. It starts at x equals -2, which would be here. So I have my open circle on x is -2. That's where my open circle would go, and then I'd go down 1 and over 1 because that's my slope. And it looks like this. And then x is -4 would start also at -2 on -4. This time it would be a closed circle because it's greater than or equal to 2, and then I go this way. Okay? So we're going to use Desmos to see the basic shape of it, and then we're going to graph it on our paper using what we know about slopes. All right, let's do the next one. I hope I'm not making you car sick by changing the windows. Okay? So this first one is y equals 2x plus 1. And my restrictions, to get my restrictions, remember I go to ABC and I get the braces. And this is x is less than 1. And I see what it looks like. So I see that it is starting on 1, because these are broken up in 2. So 2, 4, 6, 8, 10. Okay? So I can see, if I want this to be 1 to 1, yeah, like that. I can see, maybe, there we go. I can see that this is at x equals 1, and then I'm using my slope to go down 2 and over 1. So I'm going to go over to 1. It's at 1, 1, 1, 2, 3. So I'm going to go to 1, 3. I'm going to put an open circle, and then I'm just going to use my slopes to go down 2 and over 1. Down 2 over 1. And I draw my line again, and I have an arrow. And then for the second one, it's -2x plus 3. So we do -2x plus 3. And it is starting when x is greater than 1. So I go to ABC, I get my braces. And then I do x is greater than or equal to 1. Okay? And so I notice that that one starts at 1, 1. That's where that starts, at 1, 1. So I'm going to start at 1, 1 on mine. I have the slope of -2, so I'm going to go down 2 and to the right, go down 2 and to the right 1. And this circle is going to be closed because of the x is greater than or equal to 1. Okay? So that is how we graph with the Piecewise with Desmos, and then we also want to be able to graph by hand. We want to notice the important things to do is where I have an open circle and where I have a closed circle. Okay, I'm going to do, we have 2 more to do. Why don't you stop the video and why don't you try number 3? Okay? So stop the video, try number 3, and then we'll come back to it. All right. For number 3, we're broken up at x equals 2. Sometimes what I like to do is I like to take just the light line and show me. That means that when I'm graphing my graphs, they cannot cross that line. So I'll have one on the left and one on the right. So this one would be -8 and 2. And it's got a slope of -2, so it's going to look like this up. So this graph, I think, would look like that. It'd have a closed circle. The next one would be at -1. And it would have an open circle. And since it has a slope of 4, it would go up 4, 1, 2, 3, 4, and over 1. And it should look more like that, okay? And so you should have also been able to graph that on Desmos as well. All right, let's do this third one together because it looks just quite fun with 3 little parts to it. Don't you just love that one? So we're just going to put all 3 of those. We're going to do them the exact same way. We're just going to have 3 in Desmos. So we're going to have x, we're going to have y equals x minus 1. And go to ABC, get our braces, and our braces, we're going to have x is less than or equal to 2. And then we go to our next line. We have y equals 2x minus 1. We get our little braces, and we're going to have from, now how do I put that in? I put that in the exact same way. The way it's typed, -2 is less than x is less than or equal to 4. And then my last one is -3x plus 8. And go to ABC, go to braces, go x is greater than 4. Okay. Oh, why am I not restricted? Oh, because I didn't do y equals on that one. See, that's the importance of doing y equals, I think. Now it still looks jacked up. Why does it look jacked up like that? We have, oh, because this should be x is less than -2. Then we have -2 to 4, and then x is greater than 4. So that's what it looks like. If we want to see the whole thing, I'll make it bigger so we can see it. There we go. And we have our 3 little parts, and then you would just put that on your graph as well. Okie dokie, boys and girls. Alrighty, so that's how we graph a piecewise function, and tomorrow we will evaluate the piecewise function. So what I'd like for you to do now is I'd like for you to go ahead and finish up on and do problems 5 and 6 on the next page. Okie dokie, use Desmos and then use it on your own, and we will discuss it next time I see you. Have an amazing day.